much. Thank you. Thank you very much. Fantastic. That's impossible to follow, so bear with me. Thank you, Mike. I always enjoy your talks, and I'm going to talk about embryonic loss today, and it's always a big topic because of the frustration associated with having cows diagnosed pregnant, but then later diagnosed not pregnant. And a couple simple messages to begin with, and then we'll move on from there. So I think the first thing that's important to remember is start with a clean, healthy cow and good body condition. And what I find so interesting about that is the milk quality guys talking about the importance of cleanliness, and certainly cleanliness is important beyond the milking parlor. The second thing I would say, good cows make a difference. Good cows make a difference, particularly in the genomic era. And of course, earlier today, they spoke about the health traits and the importance of health traits in terms of milk quality. But health traits are important in terms of, very important in terms of reproduction as well, and sort of maintaining that embryo. So although we place about 8.7% weighting on fertility and calving, don't forget that most of these health traits are have positive genetic and phenotypic correlations with fertility as well. So you can't really, when you think about embryonic loss, there's no way to avoid the basics of clean cows in good condition with good genetics. So the third thing I would say is environment matters. And again, it's sort of ironic that this morning we talked so much about the barn environment and the parlor environment in terms of good milk quality. And let's not forget that the calving environment is important as well. If you can do everything you can to reduce sort of bacterial load around calving, it's critical for maintaining a healthy uterus. And if you can maintain a healthy uterus, get a cow through the transition period with a healthy uterus, you're much less likely to have embryonic loss. So this is one of the big keys. Now, I would say you start with a clean environment, but that's not the end of it, because we all know that lots of cows calve in clean environments, and you still get some cows that will get metritis. But let's just remember, let's not make it any worse for that cow. Let's do everything we can to basically keep the bacterial load as low as possible around the time of calving. And then it goes to the 3 steps for getting cows pregnant. Step 1, healthy uterus. And that's why I go back to the transition period. You know, if you ask really great producers, you ask them, what are you going to do? What's your key to getting this cow pregnant? They don't, if you ask them that question, they don't say stuff like, well, I add this to the ration, or well, I do this when I breed the cow, or I do horn breeding, or I use this, that, the other thing. They usually say, well, I take care of my transition cow pen. I take care of my transition cow pen. If I can get that cow to transition well and stay healthy, my repro's going to go great. And a lot of that transition cow pen has to do with starting with a healthy uterus. And we'll talk a little bit more about that in a second. Second thing, healthy ovary. Healthy ovary that basically makes progesterone, which supports a pregnancy, and secondly, maintains a healthy oocyte, because you have to have a healthy oocyte from that cow so that cow can get pregnant. And thirdly, of course, you have got to put semen in the cow, okay? I mean, around Christmas time, I used a joke, the only thing that ever got pregnant was the Virgin Mary, right? Well, we don't got a bunch of Virgin Marys in our herd, okay? They need semen in that cow to get her pregnant. So steps 1 and 2 of that process, the uterus and the ovary, are heavily dependent on management as well as the endocrine, metabolic, and disease state of that cow that supports milk production. And everything depends on people, including the third step, which is putting semen into the cow. So the reason it's so hard, the reason fertility is so difficult is because it's basically a miracle that it works in the first place. I mean, if you think about what has to happen here, you have to start with a single cell, which is fertilized by another single cell to create a single cell, and that single cell has to survive in a 1,600-pound cow to produce a calf. And all along that process, everything can go wrong. There's so many places the train can fall off the track. The cow might not be cycling. The cow might not producing normal concentrations of progesterone and estradiol to support that pregnancy. Her oocytes might be messed up. Her uterus might be messed up. And if if those things aren't messed up, then she might undergo embryonic loss. And that's the frustration. Now, everything begins with fertilization, and I'm going to talk about the different stages of embryonic loss and when they occur, but I want to just set the stage a little bit. It starts with fertilization, which is a miracle in itself. Two haploid cells coming together to making a new individual. And then it goes through the stages of early embryonic development, most of which occur early, the first week inside the oviduct of the cow. And let's not forget, you've got to go from a one-cell embryo, and that one-cell embryo has to go all the way to the blastocyst stage, where it basically forms the fetus as well as the placenta. But what does this one-cell embryo during its first week of life have to do? Well, it has to form the two cell layers, the fetus as well as the placenta. It has to turn on all its genes. That's a quite heavy lift, going from a genome that's not doing anything to the genome that's now making all sorts of proteins to support this development. It has to compact, cavitate, and finally it's got to hatch out of the zona pellucida. Once it hatches out of the zona pellucida and it enters the uterus, it goes through the next heavy lift. That is to occupy the uterus and prevent the corpus luteum from regressing, because we know if the corpus luteum regresses, that embryo will die because it's not supported by progesterone. That's all got to happen during the second week of pregnancy, where that embryo continues to develop, becomes spherical, becomes tubular, and ultimately, once it becomes tubular, it has to block the release of prostaglandin F2 alpha from the uterus so the CL does not regress. And the way it does that is it produces a chemical called interferon tau, which prevents the uterus from releasing prostaglandin, therefore rescuing the corpus luteum so it may continue to produce progesterone so that cow can maintain the CL and continue to be pregnant. So now we have a pregnant cow. You've rescued the CL. There's progesterone in place, but there's a lot more to do here. And the things that have to happen after that is this embryo must form a placenta to feed itself. And the placenta is not fully formed by 28 days or 30 days. It's not fully formed by 45 days. It's not until about 60 days of pregnancy that that placenta is fully formed and attached. So the period of embryonic loss that we all talk about, you preg-check cows at 32 days after breeding, and then you got to recheck them at 60 days. That recheck is to determine whether or not that placenta has fully formed, and we lose about 10% of the pregnancies because that placenta fails to fully form. But what I'm going to tell you today is this stage of embryonic loss is peanuts compared to the other stages of embryonic loss, which all occur before this time. And I want to explain the other stage. We're going to talk about this stage of embryonic loss because that's the only one we really know how to deal with. But there's a lot more embryonic loss that occurs before this time, and I want to talk to you about that. So the thing to remember about embryos, to think about, is they are quite dynamic in the way they grow and develop inside the uterus. These two embryos are 35 days of age. Those two embryos, which are both 35 days to that's the pregnancy-associated glycoprotein concentration for those two embryos. And you can see the upper line with the filled circles is the big one, and the other one's the little one. So within this tremendous biology, there's tremendous diversity in the capacity for these individual embryos to develop. And some of this diversity in the capacity of them to develop probably explains in part why some embryos live and other embryos do not live. So we're going to talk about the different periods of embryonic loss, and Milo Wiltbank defined different periods of embryonic loss, which make a lot of sense for me. The first is the first week after pregnancy. I told you about that. Week 1 during this early cleavage stage, embryos in the oviduct. The next one is between week 1 and basically maternal recognition of pregnancy, that period in which the embryo is signaling its presence to the mother. The third period is placentation, and I won't talk about too much after placentation because most of the embryonic loss after day 60 is more disease-oriented, infections sort of oriented, and it's usually quite low. Most of the embryonic loss occurs during the first week of the embryo's life. Between 20 and 50% of cows become not pregnant 1 week after you breed them. So you may feel good, but basically a week after you breed them, half those cows are no longer pregnant because those embryos die. The next period, which is slightly lower, is this period between those early cleavage stages and when she signals the mother. And the final period, which everybody talks about and everybody gets upset about, is during placentation, and that's only 12% of the loss. It's really a minor period of the loss, but it's the only real period we can measure or understand because we can ultrasound cows and we can see it. Now, the data that really kind of got my attention was this graph, and these are grass-based cows, and this is out of New Zealand. I'll show you some more grass-based cows out of Ireland in a second. But basically, in this graph, these New Zealanders, and this is a very big study and a very big lift, they're determining what percentage of embryos that are lost and when in New Zealand cows. You can see in these New Zealand cows, they're doing pretty well with a 57% preg rate. But 16% of these embryos, after breeding, never get fertilized. So you breed the cow, but you can flush out an unfertilized embryo a week later. Never had fertilization. 15% died during weeks 2 to 7. 7% died before maternal recognition of pregnancy, and they had 5% overall embryonic loss. So that gives you a sense that really, by the time you get out here, you've already lost about 40% of the pregnancies. Now, if you look at data from Ireland, it's a very sort of similar story where they are losing about 30% of the embryos during the first week, and then about 45% of the embryos up to maternal recognition of pregnancy, and another 8 or 9% during placentation. So that's when most of the embryos are actually dying. If you look at this period of embryonic loss that we all think about, I think it's generally accepted that grass-based cows and grass-based cows in either Ireland or New Zealand, as well as heifers, it's generally accepted that embryonic loss in these grass-based cows or heifers is pretty low, and that embryonic loss in lactating cows is quite a bit higher. I don't really know, I don't have a very good sense of what embryonic loss is, for example, in beef cows. I don't really have a good sense of that, probably because they just don't do as much intensive reproductive management in beef. But it's generally accepted that we have a high rate of embryonic loss, particularly in lactating dairy cows. So the why of embryonic loss depends on when. There's a progressive decline in the number of viable embryos over time. This progressive decline ends after the placenta is fully formed, but the reasons for embryonic loss probably differ across different time points. So we're going to talk about this first week. I mean, why do we lose so many embryos during the first week? It's probably not because of the bull. It's probably not because of the bull. Sires carry things called lethal haplotypes. And cows carry lethal haplotypes as well. And it's basically a gene, is if you end up with 2 copies of that gene, the embryo will die. Okay, those are called lethal haplotypes. All sires carry lethal haplotypes. All cows carry lethal haplotypes at a very low frequency. But at best, lethal haplotypes probably only account for 1% of the early embryonic loss. So that's not a major source of these embryos dying. That doesn't mean, and your best bet on the sire side, I think we all would agree upon this, is your best option on the sire side is simply look for high fertility sires and use high fertility sires with a high SCR when they're available. On the oocyte side, it's a little more interesting. What are the data, or what are the explanations for why the egg has lower fertility, might have lower fertility, or might die inside the female during the first week? What are the explanations for that? Probably the most credible explanation goes back to this Jack Britt's hypothesis for North Carolina State. And we kind of call this the Britt hypothesis in the vernacular. It's this concept that basically the oocyte is developing. It takes about 60 days for an oocyte to develop before it's ovulated. The majority of that development occurs in a fresh cow, early lactation cow. And anything of the bad stuff that can basically circulate in the fresh cow, such as elevated BHBs or elevated NEFAs or even elevated disease molecules. I can't even think of this name right now, but elevated inflammatory molecules, that sort of stuff. All that stuff is basically picked up by the oocyte. And it is collected into the oocyte, and that oocyte has a memory of what happened during the last 60 days. And the concept is that memory it takes with it when it's ovulated. So that memory might not prevent the rest of the follicle from developing, but it clearly has the potential to impact the fertility of the egg when it's ovulated. And so these are data from this data, or these are the type of data that support that. If you take a cow around the time of, and look for subclinical endometritis. And the way you would look for subclinical endometritis is by looking for inflammatory cells inside the uterine lumen. And if you take that cow and you separate cows that do or do not have uterine inflammation, and then if you take those embryos and you superovulate that cow, then you can basically ask the question, what sort of quality embryos does she produce? And so the data are that if you look at fertilization rates, for example, fertilization rates for a cow that's got uterine inflammation are approximately half of normal. So you've superovulated her, you've successfully superovulated her, but her oocytes don't fertilize very well. And the other thing is you have half the number of transferable embryos and basically half the number of embryos you can freeze. So essentially, if the cow has a uterine disease, that essentially imprints the oocyte, so the oocyte is less likely to get fertilized. So I think a lot of this loss probably early on is probably just because the cow is not producing a very good oocyte, excuse me, and you honestly cannot fix that when you breed the cow. You cannot fix a broken oocyte when I put semen in the cow. You have to fix that when the cow calves. You have to prevent all the inflammation and all the bad stuff that happens to the cow around calving. That's the message. Now, not only as you'd expect, is if you have all that inflammation, you can also expect lower pregnancy rates. And I think that's something we all sort of understand. We understand pretty well, is that all these issues that happen in the transition period tend to drop your pregnancy rate. So you need to try to address those things. Now, an interesting question that's kind of come out of all this is, well, okay, so Lucy, you're telling us that a lot of these cows have a dead embryo in them at day 7. So an interesting question is, if they have a dead embryo in them at day 7, how come I can't lift pregnancy rates with an embryo transfer? If the embryo's dead and the CL is otherwise there, shouldn't I be able to just do an embryo transfer and recover all that fertility? And the bottom line is you cannot. And that's one thing we don't entirely understand. And this is sort of addressed in this article by Pete Hansen. And the question is, how come? Why can't I put a good embryo in there and really jack the pregnancy rates? But if you look at these data, these are also data from the same study I showed earlier. This is the embryonic loss when they breed the cow with artificial insemination. That's the embryonic loss when they do fresh embryo transfer. That's the embryonic loss when they do frozen embryo transfer. I mean, it's virtually the same. So basically, they do that embryo transfer and they flush to see if that embryo is there, a week later, and nothing is there. And I think that's really interesting, and I don't think we totally understand that. But I think one thing could be true is when we do embryo transfer, and when we evaluate an embryo under a microscope for fertility, that has got to be one of the crudest tools available to determine whether that embryo is actually viable. Anybody who's in the semen industry knows very well we can do a lot of tests on these guys and kick out the really bad ones, but ultimately semen has to be tested in the cow. That's higher conception rate. You can't test everything about a semen sample under a microscope. You can get a lot of it, but not everything. And the same thing is probably true with embryos. I don't think we say those are grade 1 embryos and stuff, but that's just a microscopic evaluation. Maybe we need to think a little harder about how to really identify embryos that will survive in the reproductive tract after transfer. So the next period of embryonic loss is this period up with maternal recognition of pregnancy. And of course, going up to maternal recognition of pregnancy, that's all about progesterone. How do I get an embryo to accelerate and grow faster inside the uterus if it's already there? And of course, the classic way to do that is get the progesterone up. So that's why everybody talks about progesterone. Metabolism progesterone, feed this to increase progesterone. You're trying to get the progesterone up so the embryo grows faster so it can signal the mother and not be lost. That's the whole idea about progesterone. And these are the data that support progesterone. So this is data from Oklahoma State. It's quite a while ago, but there's tons of data like this. You can see these are conceptuses. I don't know, there must be about day 16, 17 conceptuses. Control animal, progesterone-treated embryo. You can see the conceptus is a lot bigger. Conceptus is making a lot more interferon tau. All good. So that led to the sort of years and years of attempts by people to supplement progesterone to increase pregnancy rate. If we supplement progesterone, treat cows with progesterone, elevate progesterone, we got to get more pregnant animals. But when you do the meta-analyses to look at that, when you really study that, what you find is there are almost equal number of studies that say progesterone supplementation improves fertility, shown here, and progesterone supplementation has either a negative or no effect on fertility. So basically, I think despite years and years of research, we really can't demonstrate that although progesterone might be good for an embryo and help it grow, there's no real solid evidence that progesterone is going to lead to more pregnancies in the end. There's a little bit of, some people believe if you got a cow that's not right or she's sick or whatever, maybe supplement with progesterone, usually during the first week after breeding, but the data are not very consistent. And I would also say the other way to get progesterone up is either by treating cows with GnRH 1 week after breeding or HCG 1 week after breeding. Yes, that will increase progesterone, but the data generally don't support that as a general mechanism to prevent embryonic loss or stimulate these cows. It might help a little bit in cows that are in poor condition or got some other issues. I think that's what the data would say. But in general, you just can't jack up a cow on progesterone and expect to fix some of these problems. So the last period I'm going to talk about is placentation, and this is kind of a little bit more about what we work on in my lab. And there's a lot of reasons. Milo, when he wrote his paper, he defined a lot of things that are associated with embryonic loss. And failure to cycle, sure, that's true. We want cows to cycle before the breeding program because cows that cycle before the breeding program have better fertility. That's very clear. Parity, farm, obviously. Change in body condition, losing too much body condition is bad for fertility. Uterine disease and non-uterine diseases are bad for fertility. I want to talk about uterine disease because that's what I've been kind of alluding to all talk long. And there's lots of reasons, and I've sort of hit pretty hard in transition cow, transition pens, and fresh cow pens and stuff, because I do really think that's where that's where the action is. That's absolutely where the action is. Because let's face it, you could take a half-decent senior in animal science, and you could say, okay, draw out double obsync or pre-sync obsync or whatever, and you can draw it out on the page. We got lots of ways. I got lots of ways I can make an ovary do what I want it to do. I can regress the CL, I can make it ovulated, I can synchronize the follicular wave. I know exactly how to do that. I can get them to cycle. You ask that same student, you ask a veterinarian, you ask a senior repro guy, how do I fix a broken uterus? Well, you're going to infuse antibiotics. Yeah, okay, good luck with that, all right? There are no approved antibiotic treatments for metritis in America. You treat metritis to deal with the fever and the loss of appetite and to make the cow feel better. It has never been labeled to make the cow more likely to get pregnant. There is no label claim on pregnancy. So don't give me that. I'm looking at Mike. He's like, yeah, Lucy, thanks a lot. All right, but there's no label claim on pregnancy. Okay, that means you should treat them if they have metritis with XNL or whatever. I don't know all the names. But don't expect okay, Mike can argue. You can ask me a question later. But anyways, you can ask me a question. The label claim's not there. In New Zealand, Australia, they do this thing called Metricure. You can infuse that stuff. It's really hard to fix a broken uterus. It's hard. It's a next level of hard. Now, I'll throw out a bone to Mike. Genetics do help a lot. A lot. Okay, a lot. So the reason it's hard is because you are dealing with, when you talk about metritis, you are dealing with lots of different things in that cow. You're dealing with some cows who just never clear the infection. They have an infected uterus, and it's really hard to get a cow pregnant with an infected uterus. You're dealing with scar tissue in the uterus. When you have damage to the uterus, you develop scar tissue. Now, I don't know about the last time you guys developed a scar, but the last scar I had didn't just go magically disappear in 60 days during a 60-day voluntary waiting period. You've got morphological memory, some residual inflammation, and then some cellular memory. And I want to talk to you about that. The thing about the immune system is that the immune system is responsible for dealing with your uterine disease. That's inflammation. And inflammation, we all like, you've got to get rid of the inflammation. No inflammation. Yeah, right. Okay, that's true. But you're going to have some inflammation because the inflammation is the only thing that basically restores normal uterine function. You're going to have inflammation. But after that inflammation is gone, after 60 days postpartum, after that's gone, typically the immune system has not left the uterus. It leaves behind residual elements, in this case, these lymphocytic foci, throughout the uterus. They're brown spots of these foci. These are collections of immune cells that are left behind in a cow with metritis. And they stay there and prepare themselves for the next potential infection. The uterus leaves behind these islands of immune cells throughout your cow's uterus, waiting for another infection. That's what the immune system does. So this cow's 100 days out, and you can see her uterus is dotted with these foci. And basically, when we study this, we continue to study this, what you find is if there are foci present, in this case, the ones with the dark bars have a high number of foci present, or if there is inflammation, in this case, the cows with the dark bars have inflammation, you can say the placenta weighs less. And basically, what that says is the presence of inflammation inside the uterus, these placenta are between 28 and 42 days here, it basically slows up the development of the placenta. And the question becomes whether or not, when that embryo is developing and it finds one of these inflammatory sites, whether it really is not sure how to deal with that chemical signaling. You have to remember that inflammatory, these cells here are going to produce chemicals. They're called cytokines, or produce hormones. This embryo here produces a cytokine. It's called interferon tau to rescue itself. And the question becomes, does that inflammatory environment in some way, shape, or form confuse that embryo in such a way that it just gets confused and just stops developing and you lose it? And that's my guess. That's probably a major contributor to embryonic loss. Now, if you wait long enough, and now I'm just playing right into Mike and I are friends, so don't read anything into this whatsoever. If you wait long enough, if you want to wait long enough, these are the number of foci in a cow with metritis or no metritis at 80 days postpartum. This is the number of foci in a cow with metritis or no metritis at 165 days postpartum. I think if you wait long enough, that inflammation is probably going to resolve, but the question is, do you want to wait that long for that cow to get pregnant? And that's the issue. So you always see cows. It's not that when a cow has metritis, she'll never get pregnant. She will get pregnant. It's just going to take more time. She may never get pregnant. We have lots of cows that never get pregnant, but it's going to take more time. And the question is that time worth keeping that cow? So what we're currently working on in our lab is this concept of inflammatory memory. And that's this idea, inflammatory memory is the idea that your tissues, a cow's tissues, they have the capacity to remember inflammatory events. Their DNA is imprinted by the presence of inflammation. Your DNA is imprinted by the presence of inflammation. And so what we try to understand is, how does metritis imprint a tissue and leave a lasting imprint on that tissue. Now, when you have a tissue that's imprinted, that means the DNA structures, it depends, but it means the DNA is changed. Now, you can erase that imprint, but it's a different type of chemical and it's a different type of approach. And that's what we're kind of working on. How do you have a tissue that's damaged and erase the DNA imprint so it can function normally again? So can early embryonic loss be reduced in cows? The answer is yes, through adopting best management practices, okay, and that has to do with your transition cow pen, and developing new and innovative tools based on sound science. Those are some of the things we're working on, sort of how do you erase an imprint? How do you make that uterus healthy again? While we wait for science, we follow Fricke's rules for getting a cow pregnant. It's Paul Fricke, good friend of mine, okay? How to get a cow pregnant? Rule 1, put semen in the cow. Yep. Rule 2, if she's not pregnant, refer to Rule 1, all right? That's how we deal with embryonic loss. Cows with embryonic loss are not pregnant. You should apply, if you want to keep the cow, Rule 2 to that cow. So the question is, I did this graph forever ago, but it's an interesting question. When should we rebreed cows? When should we do pregnancy diagnosis on cows? And when should I rebreed her? And a lot of guys are like, well, I remember when we first started doing early pregnancy diagnosis, 28 days, 20, something like that. Man, the rub on that is I don't want to do an early pregnancy diagnosis because I'm going to preg check that cow and I'm going to come back at day 60 and 10% of them are not going to be pregnant. And I don't want to deal with that. That was the reaction. You have to be old like me to know that. That was the reaction. Why would you preg check on day 32? I'm going to have to recheck her. And I always tell, and I think it's obvious now because you guys have all been through so many of these seminars, but you preg check to find the ones that are not pregnant. I can do nothing. I can give you nothing to fix a cow that is 32 days pregnant, but will lose that pregnancy. I can't give you anything. I can't give you something to inject her with. I can't do a thing for that cow. But I got news for you. I got something I can do in an open cow. I can put semen back in them. I got lots of ways to handle open cows. If you had a pregnancy test that told you whether or not that cow was pregnant at 7 days after breeding and told you those 40% of those cows, would you use that information? Well, Mike's going, no. But, oh yeah. I'd turn those things around so fast you wouldn't believe. I'd give them prostaglandins, generation, and I'd breed them 2 days later. And so the question becomes, everybody's familiar with a day 32 resync, right? That's a day 32 resync, timed AI resync, and that's a 42-day interval. But that's why the activity collars have become so, why have activity collars and tags and everything become so popular? Because it's a way to diagnose pregnancy before the resync. It makes perfect sense. It makes perfect sense. It's basically a pregnancy diagnosis before your resync, and it's an effective way to do pregnancy diagnosis before your resync. I tell beef producers, why do I put a bull in with my herd after I breed AI? Because he not only does your pregnancy diagnosis for you, he does your insemination for you as well. And that's what the collars are. So the question becomes, if I could diagnose pregnancy earlier, would I do that? If I had a pregnancy test for day 17 after breeding, would I do that? And so this just published in Biology Reproduction in 2025, a pregnancy test that works day 16 to 18 after breeding. Well, day 16 or 18 after breeding, if you could get a reliable pregnancy diagnosis then, would you rebreed that cow? Cut your 42-day interval in half. And so basically the answer to the question is, yeah, you would. Because essentially, there's your first AI, there's your day 18 test. If she's pregnant, you leave her alone, right? But she might undergo embryonic loss. Whatever, you got collars on them, you got a resync still planned for her. If she loses the embryo, you'll get her with something else, but you'll get a first crack early. If she was open, I'd probably give her prostaglandin F2 alpha. 3 days later, I'd gene age and breed her. I'd time breed her and breed her by 21 days after first breeding. That would work. Now, obviously, if she's pregnant and loses the pregnancy, you got activity system on her. And if that doesn't catch her, you just take her through the regular resync. So it'll be interesting to see what happens with this new pregnancy diagnosis to determine, based on interferon tau, basically determine whether or not that cow was pregnant 17 or 18 days after breeding. With that, that's my story, that's my podcast, Dairy Digressions. Thank you very much, everybody.